So in this presentation, I will discuss about the structure and operation about the different types of fuel cell models. Overall, 3 days workshop will cover the modeling and advanced simulation together with the different systems containing the fuel cell and its uh, control. So here, uh, why the electric cars are very important nowadays, because combustion engines are very undisputed technology for automobile transport for years. But nowadays, due to the deficiency of the conventional sources, we have another scope of the energy source, that is battery and fuel cell. The electric vehicles never take the petrols, and they are friendly. There is no any byproducts which are toxic and harmful to the environment, and electric vehicles can save our environment. So electric vehicles are very cheaper and more practical as compared to the combustion engines, because for the same cost, electric vehicles has longer range. So as we think about the maintenance cost, the internal combustion engines have much more uh, cost as compared to the EV during the maintenance and repair, and EVs has comparatively low loss. So, due to this reason, the governments are trying to motivate the consumers to shift towards the electric vehicles. So, we here compare about the battery powered vehicles versus fuel cell vehicles. So what is the main problem in the electric vehicles is that the shorter range of battery, shorter range of drive for one charge, and during the charging it takes high time. So it has very long charging cycle. So also we have the complex design of converters and control system. So another part is that the there are costly elements which are involved in the battery, specifically lithium. So the battery cost is very high, and once it is out of order, we have to invest a high cost in the battery. So also, if we see with the viewpoint of environment, the lithium ion battery has the environment a bad effect to the environment and health. So fuel cell electric vehicles are better alternative to the battery electric vehicles, as we can have the bulk energy source in the form of instantly filled fuels in the electric vehicle. So fuel cell car can easily be recharged by replacing the hydrogen containers in the gas stations. Fuel cell cars don't produce pollution like uh, other uh, internal combustion engines, and so overall we can see that the fuel cell cars have more better capability and properties than battery powered electric vehicles. So also we can use the hybrid system involving the fuel cell and battery together. So here now we see what is the why the hydrogen is important as a sustainable alternative to electric vehicles. Fuel cell is still not fully adopted because there are some limitations. The limitations of the fuel cell are widespread filling station network is required. Second is that the durability of fuel cell systems for certain temperature and humidity, means for different temperatures and humidity the performance of fuel cell changes. And also uh, second very important factor is that key fuel cell vehicles on road stack durabilities from 29,000 to 75,000 miles for one life cycle. But for electric vehicle, other internal combustion engines, it is 150 k miles of lifetime. So we have a challenge to increase this lifetime of fuel cell up to this range, which is generally available in the internal combustion engines and other types of engines. So we can see that hydrogen has a huge potential as clean and green energy, uh, as green fuel. Hydrogen is emission free, and hydrogen also decarbonize different sectors of uh, life and industry. Uh, uh, Hydrogen is carbon-less production, and it is very essential green energy source. The production of green hydrogen encompasses several methodologies. Production processes have different advantages, applications, and challenges. Technological improvements and investment-driven policy, decision for mass deployment, and commercialization result in net zero global economy. So, for adoption of this fuel cell technology, the different critical challenges and technological advancements are required to be met. Now here we discuss how the hydrogen can be generated by the water. The hydrogen generation is the first step of utilizing the hydrogen in the fuel cells. So we first discuss about how the hydrogen is generated. So basically, the most initial technology is uh, generating the hydrogen from the electrolysis of the water or by the two-step solar thermochemical cycle. So in the electrolysis process, we have the decomposition of water to hydrogen and oxygen. When the hydrogen water is decomposed to the hydrogen and oxygen, there is transfer of proton and electrons from different paths. Proton travel through the electrolyte and electrons travel through the uh, conductor. So in this way, the hydrogen, ox oxygen and hydrogen gases are coming out from uh, this electrolysis setup. So again, we discussed the two-step solar thermochemical cycle for the generation of oxides. In this method, we have two cycles, two steps. First, we have some oxide of the metal, which either converted to the lower valence metal oxide, like we have Fe3O4. We can convert it to Fe2O3 by heating it. Okay, some of the oxygen is emitted out of this reaction. So the metal oxide is typically heated at 1200 to 2000 degrees centigrade, and oxygen is isolated, as we can see in this diagram. Is it visual? My cursor is visual there. Movement of cursor.
Yes, sir, clear.
Okay. So here at very high temperature, there is a solar thermal collector, and a solar thermal collector will heat the chamber, that is solar reactor, and in the solar reactor there will be higher valence metal oxide. This metal oxide will be converted to the metal as well as to the oxygen. The oxygen will be emitted, and this metal, which is very heated condition, this is again reacted with the water. When it is reacted with the water, the there is formation of metal oxide and hydrogen together, as we can see here by the reaction shown in this black second. Okay, so basically the solar is very important for this two-step thermochemical cycle. Also, we can use alternative thermal system for generation of this high temperature. So in this way, we can get the hydrogen and oxygen, both gases. We have several other methods of hydrogen generation also. We have the methane pyrolysis. and thermal splitting. We can see here that when we heat the methane is converted into two parts, that is carbon and hydrogen. So in this way we get the hydrogen. Another conversion, another system of generation of hydrogen is reacting the uh, methane with the hydrogen with the water at and heating it. And during the heating, there is the carbon monoxide and hydrogen as byproduct. So hydrogen is emitted from the first stage also. In the second stage, the carbon monoxide and water is mixed together, and this forms the carbon dioxide and hydrogen. So ultimately, we get the uh, carbon dioxide and hydrogen as the byproduct. Means main product is hydrogen, and byproduct is carbon dioxide. Third is steam reforming of natural gas. Here CH4 and CH4 is the natural gas, and it is uh, reacted with the water, and the same process follows here. Further, another method is coal carbonization or gasification. In coal carbonization, we have coal, that is 3C plus O2. We heat it, and it is reacted with the oxygen, and then we mix it with the water during very heated condition. So in that condition, the hydrogen and carbon monoxide will come out. This carbon monoxide and hydrogen, carbon monoxide and water will again react at a high temperature and make the carbon dioxide and hydrogen. Okay, so again, if we see C24H12 is another chemical which is formed after the reaction as a carbonic material. Then reacting it with the hydrogen oxygen, it will generate the carbon monoxide and hydrogen. So in coal carbonization or gasification, like here C24H12 is a gas which is reacted with the oxygen. This forms the carbon monoxide and hydrogen. So in this method, we can see that the main product is carbon monoxide, hydrogen, and carbon dioxide. Here you can see the carbon dioxide. Here you can see the carbon monoxide. Here you can see the carbon monoxide and hydrogen. Another method is alkali metal heating in presence of humidity. If you have some alkali metal like Na or Ca or potassium, these metals are uh, heated in high temperature and then reacted with the water. In that case, we will have the sodium hydroxide, that is the base, and the hydrogen gas. Further, a last method which is not given here, I will give you that generally urine. Urine has a large quantity of ammonia and hydrogen oxygen. So heating the urine has a requirement of lower energy investment as compared to heating the as compared to giving the energy to the pure water to decompose into the hydrogen and oxygen. So this method is also one of the method here not given. I have told you. So now, what are the developments? As we have the first step that we require the oxygen and hydrogen. Mainly, the hydrogen is the main requirement because oxygen is already available in the air. So we have discussed about that, the generation of hydrogen. Now we will discuss how the fuel cells have been developed. So fuel cells have been first discovered by G.H. Sobin and first developed by the William Grove in 1839. Grove was experimenting on the electrolysis, and in that electrolysis process, he has seen that some recombination has given out the electric current. So from there, he has shaped the concept of fuel cell. 1930 to 1950, the Thomas Bacon worked on developing the alkaline fuel cells and developed first stack in 1958. The technology was licensed to Pratt and Whitney, where it was utilized for the Apollo spacecraft fuel cells. So what are the fuel cells? Fuel cells are energy producing alternative to conventional combustion engines. Means we are trying to replace the energy source in place of petrol or diesel. The fuel cell will be the a better alternative for energy source. In fuel cells, the chemical energy is converted into a usable form of energy, like we have some reaction and we get the electrical current. So usual form is electrical energy, and chemical energy is that mixing of these gases. So in the anode and cathode, anode that is positive electrode and cathode that is negative electrode, we feed the oxygen and hydrogen together, and in this way the electrons are exchanged. These electrons do not travel through the electrolyte, but these travel from the external conductors, and they come out of the load. And during the exchange, the electrolyte works as the medium for transfer of these protons uh, as generated from the hydrogen gas. So electrical circuit and chemical process then completed uh, when oxygen and hydrogen are mixed and the returning electrons are brought together to from the water. So here the advantage of the fuel cells over conventional energy sources that it has a zero or very low emissions. It has lowest greenhouse gases as per fuel used. Some fuel cells use the carbonic materials or like methane and other things. So they may have some greenhouse gases. Here in the fuel cells, there are no moving parts, and mostly there is no requirement of any maintenance. Fuel cells have high life cycles, low cost of energy production, and very weak. The fuel cells are very modular in design. Means they are properly, they can be properly fitted in a location, and they are very compact size. And also we can increase the size according to our requirement. Like we can stack together a large number of fuel cell units. We have a high efficiency of energy production in the fuel cells. There is a linear relation of amount of energy released from the fuel cell as per the given fuel amount. Water is the secondary byproduct, which is not harmful for the environment. So fuel cells are, we can say, ultimately the environment friendly new energy source, which has fast and high efficient performance. So here we see the construction and working of the fuel cell. Fuel cell have mostly the electrolyte sandwich between two thin electrodes, and these electrodes are porous. Means when we give the hydrogen and oxygen, the hydrogen and oxygen are easily accessible to a, electrolyte portion. Means if the anode and cathode is porous, both the gases will meet inside the electrolyte. Okay, so this is the importance of porous anode and cathode. Without the porosity, the fuel cell will not work because the electrolyte will not react with the hydrogen and oxygen. So hydrogen or hydrogen-rich fuel is fed to the anode, and here the catalysts also play important role during the fuel cell operation. So catalyst improve the reaction and transfer of electron in these elements, these gases. At the cathode, the oxygen combines with the electrons and in some cases with species such as proton water. So we can see here that this is the a picture of fuel cell and its operation. Here we have fuel, that is mainly the hydrogen is mainly called the fuel here for the fuel cell, main fueling, and oxygen that is means the oxygen. It can also be the air, and oxygen air or oxygen, we can see this is the inlet for that. Okay, so here once the hydrogen is given, the electrons are released to this direction, and there is positive hydrogen ions which transfer from this plate, this anode, to here, and this is porous. This is the electrolyte portion. This is positive proton H plus, and this travels to this portion, and in this way, here oxygen which is given from here reacts with the electrons coming here, reacts with the electrons coming here, and makes the oxygen ion, makes the oxygen ion. Here oxygen ion and hydrogen ion together mix to make the water. So we can see here how the complete process is during the fuel cell operation. So mainly the electrons pass from the conductor and do not pass through the membrane. This is also called the membrane. Here we can see, if we don't use the electrolyte, we can use the thin porous material which is containing the salts or bases or acids. So that is called the membrane. So here we can use the electrolyte or we can use the membrane. So here the electrons will mainly travel through the external conductors and load, and protons will only travel through the membrane or electrolyte. Okay, so this movement of electrons in the external circuit results in electric current, and the amount of power produced by the fuel cell depends on the temperature of the fuel cell, the size of the fuel cell, type of the fuel cell, and the pressure of the gases, like pressure of oxygen, pressure of hydrogen. So there are different parameters. How much is the power outcome from 1 unit of the fuel cell. Here we can see the animation of a fuel cell. Here we have the porous electrodes, and hydrogen is coming. The electrons are separating. Here you can see electrons are separating from the hydrogen, and ions are traveling through the electrolyte to the porous cathode. So this is the anode and this is cathode, and here oxygen takes the electrons and converts into the negative ion, and this negative and positive ions of hydrogen oxygen combine together to form the water. So there are different types of fuel cells. First fuel cell is alkaline fuel cell, AFC. Second is phosphoric acid fuel cell, PAFC. Third is polymer electrolytic, or we can see here there are both names, means for the same PEMFC. Either it is called the polymer electrolytic fuel cell, membrane fuel cell, or proton exchange membrane fuel cell. Means proton exchange or polymer electrolyte, either term we can replace, and this is the same. We have here the name according to the electrolyte type, and here the name according to the either it is transferring the H plus or it is transferring the OH minus. Okay, so if it is transferring the there is process of H plus, then this is called the proton exchange. If there is a process of OH minus, then that is called the anion exchange method, membrane fuel cell. Here we have solid polymer fuel cell, SPFC, and molten carbonate fuel cell, MCFC, and solid oxide fuel cells. So now we have another types of fuel cells, which is mainly based on the types of fuel and oxygen. So hydrogen oxygen fuel cell is mainly we have studied till now. Hydrogen rich air gas and air. So here air has the oxygen content, and hydrogen rich gas has the hydrogen. Ammonia ammonia and air. Once I had said you that urine has the high value of hydrogen per low requirement of energy for electrolysis, and there the ammonia was the important product coming out of that process. So ammonia has the hydrogen. So this means ammonia can convert into hydrogen and nitrogen. So this hydrogen is used for combining with the oxygen present in the air inlet. Okay. Anyone is properly understanding the things inside this? Can you please respond me? Am I audible?
Yes, sir.
Hello.
Yes, sir.
Am I?
Yes, sir.
Yes. Yes. Okay. So here, synthesis gas is gases which are synthesized uh, uh, after by some chemical reactions, and then we have the hydrogen content in that, and air fuel cells. Hydrocarbon is used mainly for uh, getting out the carbon dioxide, carbon monoxide plus hydrogen. So hydrogen will be a product, and it will meet with the mix with the oxygen in the presence of some catalyst, and it will again generate the electricity through this type of fuel cell. So now we see the alkaline type of fuel cell, AFC. So here we have the uh, electric current here. Electron is transferred from here, and the OH minus here, the hydrogen H plus and OH minus. Here is you say that oxygen is coming inside this. Oxygen is coming inside this, and it is reacting. It is generating the oxygen ions. Oxygen ions react with the water electrolyte. Oxygen ions react with the electrolyte and make the hydrogen ions together, and there is the transfer of electron from this circuit. So here the main you have base type of this, like you have this electrolyte is NaOH. The electrolyte is NaOH. So NaOH has the Na plus and OH minus. So OH minus will uh, combine with the hydrogen, so it will make the water, and also the Na will recombine with the Na plus, and O minus will recombine together to make the chemical. So it will the electron will be taken from this side. So oxygen ions will be formed. Okay. So FC requires the steady stream of pure hydrogen and oxygen. Oxidation of hydrogen occurs at the anode and produces the water. Electrons travel through the external circuit. The theory is the same. What are the main challenges here? So catalyst agglomeration causes uneven wear. Means this catalyst can wear and tear the electrodes. Okay, and this will decrease the performance and endurance of the fuel cell. The electrolyte leakage through the porous electrodes is another problem. Okay. Uh, Also, because we have there is possibility of porous gases, porous electrodes provide the path for the diffusion of the gases. So in this path, porous path, the electrolytes will also leak. Okay. So leaking of the electrolytes will decrease the performance, because we will need every time to change the uh, top of the electrolyte every time and discharge the spilled out the electrolyte to the outside. Okay. So exhaustion of CO2 leads to formation of carbonates, severely limiting the performance. Sometimes the porous electrodes, like graphite is also a porous electrode. It can recombine with the oxygen, and um, it can form the carbon dioxide, and it will limit the performance. Okay. So if there is corrosion of the electrodes, there will be some additional ohmic losses occur in the fuel cell, and this will limit the current density. Another is phosphoric acid fuel cells. Phosphoric acid fuel cells are mature and very commercialized fuel cells. This is the modern and first generation. This utilizes the liquid phosphoric acid as electrolyte. The main catalyst is platinum, and it is used in the electrodes, so that oxygen and the ions recombination can easily be done, and release of the electrons to the electrical circuit can be done fastly. So platinum is the main requirement for the fuel cells. Because of that reason, the uh, fuel cells are very costly, and we can also use the nickel as a catalyst, but platinum is highly effective for the performance of fuel cells. Okay. So these platinum catalyzed carbon electrodes are retained in the silicon carbide matrix. Okay. The operating temperature is of this battery, this fuel cell is 150 to 220 degree. They have a 40% electrical efficiency, and if we use the cogeneration, if we use the cogeneration, means if the heat dissipated is the high heat is there from the fuel cell, we can use that heat to generate another form of energy, electrical energy, and we can add it. So if we use the cogeneration, it has the 85% of efficiency. Okay. So this is used in the stationary and very high reliability applications. It has the stack of this phosphoric acid fuel cell has the maximum capacity of 200 kilowatt. Means one stack has maximum capacity of 200 kilowatt. It has been already designed, and using these stacks, a large power plant of 1 to 5 megawatt have been built in some countries. So what are the reactions in uh, PAFCs? Here the again the same reaction is there. This is the gas, this is the aqueous ion of the hydrogen, and this is the electrons are released from this path. This is the porous electrode. And in the cathode, what reaction is there? Oxygen gas is reacting with the hydrogen, aqueous hydrogen, together with the electrons coming from the electric circuit, and it will make the H2O liquid. So overall reaction is this, in which we have the main um, component as water. Okay. So some of the some of the carbon dioxide present in the air can also mix, and after a certain reaction, again the carbon dioxide will emerge. So carbon dioxide sometimes plays the role in between the reaction, but mainly the water will be formed from the hydrogen and oxygen. This component of hydrogen and oxygen will be responsible for the generation of the water. Here, polymer electrolyte are proton exchange membrane fuel cells. So we have PE or PE for air. Both terms we can use for the same fuel cell. Okay. So in this polymer electrolyte proton exchange membrane, we have water-based humidified polymer electrolyte membrane. Means actually this is not the dry polymer ion conducting polymer electrolyte membrane. It is water-based humidified. Okay. If it is not humidified, then it is solid polymer. That is another type of fuel cell. So here it has a very high efficiency. They are very highly used for transportation and portable applications, because they have the lower operating temperature, They are fast startups and high power density. What is the startup of the fuel cell? Initially, if there is a because according to the current requirement, we increase the fuel of the fuel inlet in the um, fuel cell. If the fuel cell is not giving output, then we don't have the current. We don't have the current, then there is not rise in the current. Then it will not inlet the fuel, and it will not generate the voltage and current. So we need initially the startup of the fuel cell. Okay, so startup is very important process in the fuel cell. And high power density. It has very high power density. This is the main material which is used as solid polymer electrolyte, and is solid electrolyte membrane is humidified. Okay, in this type in this category of fuel cells. So Nephron is the main electrolyte membrane, solid polymer electrolyte membrane fuel cell. So here SPEFC. This is used. This is solid. This is ion conducting polymer membrane, and this have this membrane facilitates the electrochemical reaction between hydrogen and oxygen. Means this is very thin. This is very thin membrane, and it has the ion conducting. Means this is because polymers are generally assumed as insulating material. Okay, but polymer is mixed with the some conducting material so that it can conduct the ions. Okay, and nephron is the main electrolyte used here. So these cells offer a very high safety, and there is no leakage of electrolyte because we have the solid electrolyte and dry electrolyte. There is no leakage. Mechanical stabilities are also very high. There is very high proton conductivity from anode to the cathode, and it is very suitable for stationary and transport applications. Stationary means which are not having the movement. Okay, and also for the transport applications where there is a very high power requirements. Another category of the uh, fuel cell is molten carbonate fuel cell. Okay, so these carbonate fuel cells um, that target small and large energy distribution generation systems. Okay, and it can generate the 0.3 to 3 megawatt range of power. The operating pressure is 1 to 8 atmospheric pressure, 8 times of the atmospheric pressure, and the temperature, operating temperature is between 600 to 700 degrees centigrade. Production of carbon dioxide during the reforming of fossil fuels. Reforming means the generation of hydrogen from the fossil fuels. Okay, this is the reforming. Here we don't understand if you don't understand the farming term. Reforming means if you have the fossil fuels like petrol, diesel, or whatever carbonic uh, materials, we you convert that into the carbon dioxide is a secondary product and the hydrogen output. So MCFCs are not completely green technology. They are having very high reliability and high efficiency that is up to 60 to 70%. So I think whatever you have studied till now, it has higher efficiency as compared to the previous other technologies. Okay, so now we can see the reaction between inside the MCFCs, molten carbonate fuel cells. Here, the methane is reacted to the water, and this methane is reacted to the water and at a high temperature, and it generates the hydrogen and carbon monoxide. In the anode, what happens? The carbonate ion reacts with the hydrogen. Okay, here what is this? Is this a reaction on the electrodes? No, it is the reaction on in the internal reformer. What is the reformer? Which changes the carbonic fuels into the hydrogen, useful hydrogen, and another byproduct may be there, that is carbon dioxide or carbon monoxide. So here anode has the reaction of hydrogen and carbonate ion. So in this way, the water and carbon dioxide will be the products, and electrons will be emerged out of this electric circuit, and that will be the negative terminals, because the electrons are going out of this anode, that will be the negative terminal. Okay, the current will be going inside this electrode, and in cathode you have oxygen, which recombines with the carbon dioxide, formed after this reaction, and the electrons coming out from the electric circuit to the cathode. So in this way there will be the formation of again the carbonate ion, and the carbonate ion will again be available to the electrons to react with the oxygen. So overall, we can see that the hydrogen and oxygen of the air has completed the reaction here like this, and the water is the product, and the carbonate ion plays the intermediate role with, for the transfer of electrons in this reaction. Another category of fuel cells is solid oxide fuel cell. As I had said, that uh, in we can generate the um, you- we can generate the hydrogen and oxygen from the heating and recombining with the water during the electrolysis process. Also here the solid oxides can play the important role for uh, chemical reaction to the electricity. Here what happens, you have the hydrogen, and here you have solid oxide, which solid oxide means some metal, maybe there are calcium oxide, Na2O can be there. So this solid oxide will play an important role as electrolyte, and this provide the medium for the reaction, and the same reaction happens again. Electrons are released here, and the hydrogen ions will be travel through this direction, and oxygen ions will be formed here from the air inlet due to these electrons, and hydrogen ions and oxygen ions will uh, combine together in this electrolyte. So here we have the high efficiency of greater than 60%, and it has very low emissions. Okay, so solid ceramic electrolyte zirconia, yttria stabilized zirconia, solid ceramic electrolyte is used to transport the oxygen ions. Okay, so here the solid ceramic electrolyte plays very important role. So these are very compact type of fuel cells. Now if we compare these different types of fuel cells, we have the gas species of hydrogen, as this is the fuel. Hydrogen is the fuel for every type of fuel cell. Here carbon monoxide is poison that is generated in PFC, and in EFC in the carbon monoxide generated. Here the carbon monoxide is working as the fuel for this MCFC, molten carbonate fuel cell. Okay, CH4, this is the diluent, and here poison, and this is diluent. Uh, Here carbon dioxide and hydrogen, this water is used for making the electrolyte. So we can see here the how which the hydrogen is main fuel here everywhere, and most if there are some carbon or sulfur, that will be poisonous. So we will mostly prefer the first the solid compact design, another which don't have the byproduct as carbonic material or carbon dioxide or carbon monoxide. So this is for today. Dr. Khadija Akhtar. Any questions? Khadija, Dr. Khadija Akhtar.
Sir, ma'am is being outside. That's why he's not in there.
So I close now this meeting. Dr.
Sure,
Khadija.
sir. Sir, I think ma'am is not here.
Okay. Okay, I'm closing the meeting. Every can leave now from this meeting. I will meet in the next day in the same time.
Thank you, sir.
Thank you, sir.